All right, let's talk about developer joy. Welcome, my name is Sven. I'm a developer advocate, DevOps advocate, whatever, for Atlassian. And you might think, like, why is this guy staying on the stage now talking about developer joy? I mean, we actually, as developers, have the best job in the world, right? Yeah, we can just it's fun. It's great to develop software, right? I know. So why is it called? Why are you actually coming to this talk? You are enjoying your job anyway. But there's something happened in the last 10 years actually, where we just I just put it that way. Some things happened in the last 10 years, right? So if we look back 10 years ago, I was enjoying my job. I was really, really happy about it. But then all of a sudden things happened, right? The cloud came, right? Nothing. I mean, it's great. It's great. Now everything is in the cloud. It's not on any service anymore. But we had to learn new tooling: AWS, Azure, GPD, right? So we need to learn new tooling. And not only that, now all of a sudden we run things in container, right? And then we just need to orchestrate these containers somehow and observe it and just measure everything in those containers, which makes our job actually harder. And not only that, someone came around and told us we should put everything into microservices. All right, now we have to we can't call everything from everywhere anymore. We just have to design the APIs, and if something changed, we have to change it everywhere. So it actually makes our job even harder. And also, all of a sudden, we need to take care of security and governance. Yeah, things are running somewhere in the cloud. So yeah, we need to just make sure that our microservices and containers are very secure, so no one can hack them. And then someone came and talked about it's not only that, you build it and you run it, right? This whole shift left just put a lot of things on the shoulders of developers, and all of these things that just happened in the last 10 years increased the cognitive load of developers. Right? So we have to do more, right? We have to put more in our heads. We have to do more stuff in software development. So now that we just have to do more, CTOs and team leads come up and say, oh, you know what? Now we need to look at developer productivity. Now we have to increase the productivity. Okay, where does this productivity come from? I don't know. So bear with me. We're doing together here, everyone in the room, doing a short time travel. Are you ready? Please stare at the slides, and then I count to 3, and then we travel back in time. 1, 2, 3. All right. Here we are. 125 years ago. We are at the Bethlehem Steel Factory. So the Bethlehem Steel Factory had some problems in productivity. There was no consultancy companies at that time like McKinsey or something that you can just call and they improve the productivity. They just hired one guy, and this guy was called Frederick Winslow Taylor. You might have heard of him. Taylorism maybe rings some bells, right? So Frederick Winslow Taylor actually came in and said, okay, I need to optimize the factory workers. So they were producing steel. So he was looking actually at the factory workers, and the first thing he did was, okay, let's measure how fast or how long things are taking. So he just put out a stopwatch and just measured the factory workers. So someone was shuffling, the other one was carrying something. So he looked at it and said, let's look at the shuffling. What is with the shuffles? Can we not optimize the shuffles somehow so they can shuffle actually more? So the first thing that he did was gave them custom-made shuffles, the workers, and the productivity increased. Great. And then he looked at how much people were carrying in the beginning of the day and how long it took at the end of the day. And of course, yeah, if you're carrying a lot throughout the day, right, you just get exhausted, so you're carrying less at the end of the day. So what Frederick Winslow Taylor did, said, I give the workers some pauses in between, some breaks, right? I give them some breaks. And boom, all of a sudden, over the whole day, they could carry more. Great. So Frederick Winslow Taylor actually improved the productivity of the factory by 400%, right? So this is one thing, 400% more effective workers. But also he changed the way the workers worked. the workers were actually doing now repetitive tasks. They were treated like machines, right? So we can optimize the hell out of the workers, so treated like machines. And then we have the managers, yeah. And the managers were doing the thinking and just like optimizing everything. So said that's 125 years ago. All right, let's travel back in time to 2023, right? Okay, let's travel back. And let's talk about developer productivity. How do we measure developer productivity? So when I started my career, that's 23 years ago, I was actually measured in lines of code. No joke, right? Actually, my boss said, last year we added, 500,000 more lines of code. Whew, great. But we know, right, this is not a good measurement. Yeah, we learned that over time. So the next thing is just like, okay, let's see how much issues someone can do, right? So yeah, 500 issues maybe in a year, or 10 issues per sprint, or great. But then that's also not good measurements. Some are a little bit harder to do, some are a little bit less harder to do, some take more time, some take less time. So that's probably also not a good measurement of productivity. The next thing that we did is just like, okay, let's measure everything in story points. Let's estimate things in story points, Fibonacci numbers, right? Is it 3 or is it 7? And then it turns out you give it a 3 and it takes for ages, and sometimes you give it a 7 and it's just like done in nothing, right? So let's do t-shirt sizes. Maybe that's a better measurement. I don't know, maybe. Or even nowadays we measure cycle time, right? The door metric. So cycle time is also a great measurement, right? How long things take from checking in the code, merging it, to just like how long it takes to production. Or even deployment frequency. And now let's improve that. Improve the productivity of our developers, right? And improve how many story points we can do, improve the cycle time. So more pressure on the developers because of the numbers that we see out. Thank you, actually, Frederick, Winslow, Taylor, for that. So we're still in that number measurement phase, right? So productivity, maybe not the best term. Also for developers, if you say, let's increase the productivity, probably they don't really like that. So now we call it, let's improve the developer experience, right? Right? Let's improve that. That's now a term that everyone uses these days. And don't get me wrong, developer experience is more than just the numbers. It's much more than that. It's also how we work together in a team, right? Team collaboration, how's the team culture, and all those things. But then consultant companies are just like smart. They're very smart, and they say, oh, we have a framework for developer experience, how to improve it, just like remove a little bit of the burnout, and we decrease, or just like if we have more burnout, we decrease the team satisfaction. Yeah, duh, right? It's clear, but now we have a framework for that, for improving it. Great job. So, and that's why we at Atlassian, we just like looked at it and said, we don't really like that. Let's bring things back to what we really want to gain, right? We believe when developers enjoy their work, when they're doing on great stuff, productivity will increase, the experience will increase. We really enjoy what we're doing. So, 3 things. So one thing is clear: if you want to enjoy your work environment, you probably build great teams. You need a great team. You need a great culture, great environment. But what you also need is this: great developer quality. So you need to just like increase your developer quality. You want to just like work. When I work on great code, there's very well written and a great quality code base. I enjoy what I'm doing. The next thing is developer progress. So if things take no time to develop, if I can just like have an idea on Monday morning and get it into the code or get it into the hands of the customers on Thursday, wow, cool, great, I make progress. In a lot of companies, this takes months, years, right? I want to just like have things done fast. And the third thing is just like, I want to take pride in my work, right? I want to create value for the customer, so the customer really loves what they get from us developers. And I want to create developer value. So these three things makes me enjoy my job. So let's look closer at those. Let's start with developer quality, great developer quality. So if your product maybe looks like this, right? You have this shiny, good-looking product. You really love it. You look at it and your customers love it. They look at it and say, wow, what an awesome product. Looks beautiful. I love looking at it. I love using it. It's great. And then the customer comes and says, you know what? Can you just like change this little thing left there? I just like, and you said, yeah, sure. I'm just like opening my IDE and look at the code and boom, this is how it looks inside, right? We have a problem. We have a problem with developer quality then. Things will change longer to change, right? And we call it technical debt. And here's some numbers. We have done a survey at Atlasian, and here's some numbers. 42% actually of developer time is used for fighting technical debt. So it's used just like that because you have technical debt, 42%. And just 10% of developers teams manage technical debt. So these are the numbers, these are the facts. And guess what? That gives us more technical debt if we carry on with that, right? Which is like it's a spiral down. So what can we do? Short story here. Assume I write a great class here, right? This is my awesome looking class. It's very simple. It's just like doing one thing, but this is what a great class should do. It's just like great looking. I'm just like writing it, checking it in, and then say, oh, I love it so much. I love it so much, right? And then I said, okay, let's go on vacation. So I go on vacation and come back 2 weeks later and just like want to look at my awesome class again. And so I open it and say, what happened to my awesome, what? What did my coworkers do, right? This happens, right? This happens. And just like to defend my coworkers, they didn't want to mess it up. They just like said, oh, let's mess up this awesome class. No, they just like wasn't time pressure or whatever and just like put more stuff on that, right? Because maybe they thought also it's very awesome, right? But guess what? You probably, like we have coding guidelines. So coding guidelines catch this, right? You have coding guidelines, right? Yeah? Okay, good for you. So this is what the Bitbucket team has. They have them Python coding guidelines, and one of the coding guidelines is actually single responsibility system, right? Principle. So all of this that I just showed was against the single responsible principle. So somehow this would have been caught, right? Because it's not in our coding guidelines, and they have tons of other coding guidelines there. But how do you catch this? Yeah, there's some static code analysis tool, and maybe ChatGPT in the future can also catch these things. Great, but the best thing to catch this these days is actually to do code reviews, right? You do code reviews, right? Yeah, every line of code, right? Gets good reviews. Yeah. Okay. Great. But I've met a lot of teams, and a lot of teams are actually not doing code reviews or just like reviewing some parts of the code, and other changes are not reviewed. And there's a little bit of problem with code reviews, right? So let's assume I have written this code, and then my reviewer comes in and says, "What the fuck, Sven?" Right? I say, why? Okay. Next comment is then, this code is ugly. I say, oh, wow, great comment. Thank you very much, right? And I already think like, I don't want to put my code out there anymore. I don't want to just like do that. Or someone says here, yeah, it would have been nicer if you would have used a for loop. Nicer? Tell me more about it. Come on, right? That's not a good comment on that. So one thing, if you do these comments, don't be a jerk, right? Don't be a jerk when you are the reviewer of the code, right? So hands up, who has been bullied by a jerk in the last 4 months? Yeah, I know your coworkers are here, so it's fine. Yeah, I get you, right? Okay, good. But jerks are actually the reason why people hate code reviews, because what you do as a reviewer is really this. As an author, yeah, you're just like super protected, right? You can just like throw errors on everything. But as a reviewer, you open yourself up. Your work is just like under review. So you should pay attention to that when you are the reviewer, right? So first thing, assume competence from the original author of the code, right? Assume this author is competent. Then be constructive, right? Be constructive. What the fuck, Sven, is not very constructive. And also explain reasoning, right? Yeah, for loop would be nicer than a while loop. Yeah, duh. Yeah. Why, right? Is that just your opinion or what? So just make sure you just like assume competence from the author, right? Okay, let's go to the next phase. Once you are done with the code review and you merge everything back, what happens then? Then your coding, your build pipeline kicks in, and the code gonna be tested automatically, right? And then your test runs, and then you look at it, and then boom, test is red. And then you go back to your desk and say, yeah, let me just like check it, and can't find anything. I don't know why this test is turned red. What should I do? What would you do?
Ignore.
Ignore is also a good thing, yeah. Comment it out. I'm just doing rerunning the test. That's what I do, right? And then boom, it's green. Oh, okay, great. Yeah, so now I can go on. Bang. No, of course not. Okay, sorry, it's time for a commercial. Please bear with me. I'm back in a sec.
Is seeing red build after red build getting old? Is rerunning your failed jobs getting you down? Is waiting on those failed jobs to finish making you crazy? Deterministic reliability is here to help. With our handy-dandy flaky test monitoring system, we will, eventually, automatically bypass those flaky tests. For 4 easy payments of free, you too can save time, ship quality code faster, be more productive, feel so much better when you go to work every day. You will be happier, your team will be happier, you'll stop dying inside, you'll stop banging your head against your desk, you'll stop replacing computers that are in a rage against the wall. Sorry. It's just a little close to home. Call 1-800-Atlasian today to get your free flake monitoring system.
All right, yeah, don't do that. We don't have a tool out there that catches flaky tests. It's just a team that wrote this flaky test detector and made this video and broadened it out to Atlassian. So what does it do, right? So once you create the pull request, it kicks in the builds and test, of course, and then the test failed. The flaky test detector looks at it and say, oh, let's rerun the test. Test is green. Okay, great. We discovered a flaky test. Awesome. Next thing is we skip the test because it's flaky, or the code is flaky, and then just like add a comment to the pull request. And not only that, so someone can look at it and fix it, but also in the team chat, there's a message coming up telling that there's a flaky test, so team, please look at that and fix it. So this is just like one example what teams are doing to improve developer quality. But how do you measure what is good quality? What is great quality, right? How do we do that? And I think like DORA metrics are a good start, right? If you heard about DORA metrics, every team that scores high on the DORA metrics is also a high performance team. Or just like has potential for high performance teams. So you can see like change failure rate, you're measuring that, just like how many successful deployments and failed deployments, something like that, the ratio between, and then time to restore, how long it takes for you when a failure happens to restore everything into a successful deployment. So you measure these probably over time for your microservices, and then just like it's great. But what's missing is you want to just like set the bar, right? What is good and what is not so good. So you want to have non-negotiable baselines. So you just like build one, or just like establish one non-negotiable baselines for just like saying if things are just like going above the baseline in that case or below the baseline in other cases, you just like want to do something. You want to just like take the team and say, okay, we just like need to do something. What we do at Atlassian is a ritual that is a weekly ritual where we look at all those things. We call Checkops. And that's actually where the team comes together, looks at the metrics, and maybe lowers the baseline because they want to improve their quality over time, or they have to do something because they just like crash the baseline. So they just gonna talk about it. They're gonna make some goals or whatever, or just like some tasks that they want to do to improve the quality. So quality metrics on one side, and then, but not just like quality metrics, because a lot of tools are giving you a lot of metrics, but you need to just like do something with them to improve your quality. So you can measure a lot of things. I would say start with just like 2 things and not with all of the things, and then just like set baselines and also have a ritual to talk as a team about it to improve your quality over time. All right, let's jump into the next topic, and that's developer progress. So moving things forward, or with other words, what people say is like, it's the developer flow, right? How does work flow through our pipelines? And coding is probably just like, I know people have special keyboards to code faster, and this is great, special shortcuts, and this is also good. But coding is not the only thing that is in our pipeline. We all know that building and testing is one thing, and then deploying is another thing. And if building and testing takes ages, we need to improve it. So we look at the numbers, right? Building and testing, I've seen hours or minutes, or deployment can take minutes to seconds, depending on how you deploy things. And you can probably optimize everything there. But what really takes time in this pipeline is this here. And we already talked about it, the review phase. And the review phase can take days, right? You put your pull request out there, ask your coworkers to review it and to accept the pull request, and then you can merge it back. And that can take days, actually. Actually, one team is measuring that, and it takes them 3 days from opening the pull request to merge it back into the code base, right? Or into the main branch. So 3 days of working on something else for the developer, getting their heads into some other task, and then 3 days later come back and maybe fixing some things or merging the code back, right? That's probably not good. So what one team lead did actually, called Punit Aaron, and he's the team lead of the team, Aurora, sorry, and he is actually what he did is just like he went in every morning and said and pinged people on Slack and said, hey, there's a pull request out there, and yeah, people were just like saying, oh, I saw the notification, but I forgot about it, right? Because I was doing just like something else. Thanks for the reminder. I'm gonna just like do the first thing in the morning and review that pull request. And of course, yeah, the team is very, very gentle and said, okay, Punit, great job, but you don't have to do that. We built a bot that is doing that. That's just like reading all the things and just like pinging you. So they have a bot and they call it the Punit bot. It's doing that. And guess what? The time to just like where a pull request was just like open, it was just like from 3 days to 1.2 days. Great improvement, right? So they lowered the baseline, and now the baseline is 1.2 days. As I said, flow is super important for software development teams, like how things flow through from idea to deployment to getting in the hands of customers, and also back to just like getting the feedback. I'm very interested in just like flow and just like see, okay, let's compare that a little bit with traffic junctions. So how does traffic flow through traffic junctions? And the first example is a simulation where there's no rules at all. So cars can just drive and figuring their way out. The throughput here is 191 cars per hour. All right, good. Let's add some traffic lights, right? So cars have to stop, but then can full speed cross the junction. Let's look at that. So traffic lights, just like cars are just like coming, waiting, coming, waiting, and then just like full speed. And the throughput is 235. oh, that's better, right? That's better. But we don't want to work with traffic lights in software development where we just say, okay, we stop here and wait, and then we go on, right? It's a little bit more what we do is a little bit more this, like a roundabout, right? So there's, you can see like fast-paced lane where we can overtake things, but normally when there is a gap, right? If we can't just like go into the roundabout, so if we have a design task and the design team has some time, it goes in the roundabout and then we get it back in some time, right? So traffic flow is around 360, which is great. It's good. It's good. Okay, let's leave it there. No, because there's another thing called the stack interchange here, right? And if you can see, right, yeah, it looks a little bit complicated, but hey, the traffic is merging. No car is slowing down. It's maybe slowing down a bit to merge into the other traffic, but it's working, right? And guess what the throughput is? 1099. Boom. This is what we want to build in software development. This is the flow we need. And what we need for this is actually autonomous teams. Teams that can run autonomous, that not depend on, oh, is there a gap in the design work line? So we can just like slide in our task. We should just like be able to do everything on our own as a team, right? Work on our features, work as a task, as a team, right? Now you say, if everything is just like super autonomous, everyone is running in different directions, and you might be right? So we also want to align those autonomous teams, right? We want to have an alignment with these autonomous teams. But autonomous teams means also that developers are doing more tasks, and we talked about that. So now we are also designers, and now we are also testers. And now we're doing also QA. Actually, QA, that's a good thing, because the Trello team just like get in, and this was the good old days when QA was actually doing all the manual testing, responsible for the automated test, or actually for the systems that run the automated test. Great. Nowadays, like shifting left, also with that is like, oh, now the developers are doing that, right? To just like have flow. So not throw things over the wall anymore, right? So we don't have to stop and wait until we get it back from QA. Now we can do everything ourselves, which is not what we do, right? And it's not what the Trello team does. The Trello team actually established a thing called quality assistance. So the quality engineers are not just like now giving everything to the developers and drinking pina colada on an island. They are actually helping the developers to do those tasks. So they're actually educating developers to do manual testing and helping them building automated tests. How do they do that? So for example, if a developer works on a new feature, before the developer starts, they get together with a QA, with a quality assistance engineer, and talk about those things. And just like, how would you test this feature once it's done? And then they go in and say, yeah, well, there's steps here, and at the end, when the task is done, the developer takes out the manual test protocol and just like tests the feature like what they have written on before with the quality assistance engineer. And once they learn more, they need less help from the quality assistance team. So the quality assistance team can also take care of the automation of the test automation platform. So they are running this platform. They have a test database, and they take care of all of this, right? Developers don't have to do that. They just like give this task to the quality assistance people. So this is just like helping actually with increasing actually the developer flow, because still developers are responsible for most of the things, but at the same time decreasing the cognitive load of developers, because they don't have to deal with all of it. All right, now let's talk about developer flow. And sometimes we just like want new technologies into in our software development, right? Because they are increasing our developer flow, or we think they're increasing developer flow. So the Bitbucket team, actually, when they started 12 years ago with writing Bitbucket server, they did it in Scala. At that time, everyone wanted to do Scala, and they said, yeah, it's a good idea to do that in Scala. We love the programming language. We think like it gives us more developer flow. We can do more with Scala. Great, so they did it in Scala. After finding out that compile time was pretty long, right? So compile time was long, and they had problem finding people to add to the team because no one knew Scala, was a new programming language, so everyone has to just so the ramp up time was pretty tough. So at the end, they fell not so much in love anymore with Scala, and they rewrote most of the code in Java. So what I want to say with that, big companies are now having a standard of way of developing software. Just like technologies that they have settled on. Sometimes they call it's boring technologies, but it's working for those companies, right? I would call it more of an opinionated way of developing software. And it's not just helping big companies, helping medium companies to just have a tech stack. Sounds like boring, but bear with me, right? So it's a defined way also for new developers. If you just want to onboard new developers, you have documentation for this tech stack. Everything is written in this tech stack. You can move people easier from project to project because you just build your projects or your products even on a similar tech stack that you agreed on. And also it tames the whole software sprawl. You don't have to maintain that much software. You just have this tech stack. And people can now call it the developer platform. So everything is built on the developer platform, and platform engineers help actually set up those tools. So if you need a new database, you can just go under the developer platform and just get the new database. You don't have to go to the IT department. So all of this has advantages, building a developer platform. So, but you might think but I want to just use this new technology. Yeah, no problem, right? Also, you can just go in, use the new technology, try it out. Maybe you need to innovate, you need to move fast. Could be an internal startup or whatever. But what you need to make sure is that if you put that in production, that you need to maintain that for long term. Or your platform team just puts it on the platform and says, yeah, that's a great technology, we add it to the platform. And we maintain it for the rest of the organization. So still the freedom to pick what works, but responsible to maintain it long term. And you might think oh, this sounds like very conservative companies, right? Maybe, but big companies like Netflix or Spotify came actually up with that model. Also, Netflix called it the paved road, and Spotify calls it the golden path. So building on and this is not all what's on the platform. You have technologies like alerting or test tooling or CI/CD pipelines that you can spin up in no time for the whole company, system security, and all those things are just running on this platform. So what is in now great developer progress? Let's look at that. Also here we just can start a little bit with the DORA metrics, right? The deployment frequency, how often you deploy, or the lead time for changes. If you want to start somewhere, that's a good start for measuring your developer progress. Now, progress and quality are great things, right? But it doesn't lead always to success, right? If you think about Google did, right? The Google Glasses, great product, good quality. They made a lot of progress, brought it fast to market. Was it a success? Not so much. They removed it again. So what I want to talk about is now developer value. And when you create developer value, you need to just you need to think about the whole picture. So if you just think about you get the task, have this house here, and somewhere on the countryside, I guess, and you get the task, the user story, deliver food to that house. So what is the best way to deliver food fast to that house? Let's build a road, right? That's a good way. Okay, let's build a road. But if you don't see the whole picture, you built the wrong thing, right? The road wouldn't work here, right? Please build an elevator or whatever. So we also, as software developers, need to see the whole picture from the problem to the implementation. And we concentrate a lot sometimes on the solution. We grab a task, a user story, and implement that without knowing what's really the problem that we wanted to solve, or that product management wanted to solve. So this is also important. We call it the wonder phase, right? When we have the problem and we just see what is the problem in real life that we need to solve. And then the next phase would be the explore phase. where you just like have different solutions. So try out different solutions, what would work. Not the first solution is the best solution always. And then the last phase is the measurement phase, right? And measure things. Now, we as software developers are probably not involved in all those phases at the same time, right? There is some times where we are involved more, probably in the create phase, and less in the wonder phase, where product management and designers are more involved, right? And then also in the measure phase, there's also something that product management normally looks at and improves things, or just like tells us what to improve things. So product is involved, maybe like this. But it's important that we involve everyone in every phase. So we actually have milestones where we just like have everyone invited. So for example, project kickoffs. So a project kickoff is necessary to do once you want to build a new feature, where product management and developers and designers and everyone on the team, data analysts, sit together and talk about like what this project is. For building prototypes, that's probably something where developers help with to just like make it, see if it's feasible from a technical side or not. So that's where developers get involved. And then as developers are also doing demos. So they need to regular demo the software so they can get feedback from product management and from designers and from the rest of the organization. And then we have something at the end where we just like measure once in the hand of customers and feed things back to development, to wonder phase, to solution phase, wherever we want to fix things. And this is of course not looks a little bit like a waterfall, right? But actually every phase is connected and you can go forth and back between those phases. So let's look at one thing here, because this is probably a talk on its own, what we do as software developers, and that's this here, the demos, right? So how do we run demos? So demos are actually probably at the end of a sprint where you invite everyone to just like see what you have developed. And actually demos are actually open for everyone to join. So we do a recording, so everyone and put it on our internal Confluence instance, and everyone can join this demo or can just like watch the recording afterwards. So it's open for everyone. The demo is not about the implementation details that you did. It's about the customer value, the outcome that you want to create, right? So just like you talk about these things in the demo and not about the implementation details. And the third thing is it's about group thinking. So there's a whole group coming together, right? And we challenge the solution that we see. It's not about just like giving just like the developers bad feedback or just like try to improve things here. It's about the whole solution that we want to improve here. We want to build the best thing for the customers. And maybe that means like we have to stop and rethink what we did, right? As I said, these sections, these phases are connected. And then also don't forget to celebrate and recognize the wins, right? And just like say, yeah, great. Because what it is and what also this talk is about, it's just like we want to have fun with what we do. We want to create developer joy at the end. Now, there's one smart guy called Peter Drucker, and he said, if you can't measure it, you can't improve it. And I talked about this, right? I talked about measuring productivity. So measuring baselines, doing checkops, OKRs, all those things are here, right? So we measure our productivity. Does that show how productive we are? Let's take a look. So GitHub actually did a project, internal project, they called the Good Day project. And what they did is they asked their software developers, right, how productive did you feel today? Right? And guess what? Some days were better, some days were worse. We know that, right, from our own, just like, it's good. And what they then did, they correlated this with data, like how many pull requests does this person do? Was that person, can we see it in the data that this person was productive? And guess what, right? There was no correlation, right? Sad Octocat here. No correlation between the data. So can we really measure productivity like in cycle time or in lead time or whatever? I know that some people try to do that, right? They try to treat software development like a production line, like a car production line. But we are not just creating just like cars or creating the same software over and over again. Software development is a creative job, right? And some tasks take longer, some tasks take shorter. So we can't actually treat software development like a production line. That's not working. And everyone is saying that if you talk about just like developer productivity, you can't really measure it just from the numbers that we see, like how long things take, right? So here's another quote: "Measure what is important. Don't make important what you can measure." So instead of just like talking just about the metrics that we see in our software development and our productivity metrics that we have put up, we should actually put the developer in the center, right? We should just like see and ask your developers, like, what can we do to make you more productive? What can we do to optimize your joy? What can we do to make this job more fun, right? Where do we struggle? What are your thoughts? And ask your developers to do that. So what we did actually, so there's a lot of things like the space framework, if someone has heard about that. We also looked at the space framework and just said, okay, we need to do our own thing at Atlassian, doing it a little bit the Atlassian way. So what we do is actually, we just like doing surveys and asking the developers, how satisfied are you with these things? So how satisfied are you with shipping, speed to ship code sustainably? That's the first thing. Then we ask, how satisfied are you with the waiting time when you wait for something, right? Is that okay, or do we need to shorten that waiting time? How satisfied are you with your execution independence? Can you do things on your own, or are you depending too much on other teams? How satisfied are you with the access to tools, practices, and processes? How's your effort to manage external standards, like security and governance, right? Are you satisfied with it, or should we do something about it? Managing the code pipeline, ramp up time, right? How much time does it take to add new developers? Is that a long time until they are up to speed? And of course, the most important thing is, how satisfied are you as a developer? Right? So we're measuring these things, we're asking our developers these things, but not only this, because we have so many different teams, we also ask them, how important is that for your team, right? And then we put that on an XY graph here and just like see like, okay, everything that is above or in this corridor, it's okay, right? Well, if it's got below, maybe we need to improve it. If it's just like outside of it, we definitely have to do something and need to just give it to the teams and let them improve their processes. So if you want to just like try it out yourself, there's this bit.ly here, and then you can just like do the survey and see at the end how good your developer joy is. Do that with your team and compare the numbers. You can do that, and I have this barcode at the end too, so you don't have to do that now. But what you want to do is give those things, the measurements and the survey results, to your developers, and they need to try some new things, right? Like the Punit bot, right? They need to just like try it out, do something like the flaky test detector. So give that to your developers, and then also let them share the learnings, right? So the flaky test detector, they made a video and shared it with the whole organization, so everyone can just like use that in their development. So it spreads actually. Or the Punit bot, actually, they wrote a blog post about it and put it on our internal wiki. So you can just like read it, how good it is. You can just like try it out yourself, and they write about how to use it. So all those things. So here are actually the conclusion. Measurements are one thing to just like see if there's something wrong, right? Establish baselines, but also mix that up with surveys. Ask your developers, right? Give those data to the autonomous teams so they can actually look at it, learn from it, and fix things. So trying to fix things to improve the developer quality, the developer progress, and the developer value. And I always wanted to do a Venn diagram in my talks, and this is the first time. And right in the middle is actually where developer joy is happening. So work on developer joy, and don't forget to have fun. Thank you very much.